For number 10, we have that x has a normal distribution that tells us the mean for x and the standard deviation for x. And then we're going to look at various samples here of different sizes. And if you flip to page 305, that's where the information is that can help you tie all this together. So for a normal probability distribution, which 10 told us that x was a random variable with a normal distribution, so this is all true. It tells that number 10 told us what the mean was, it told us what the standard deviation was, and then it talks about samples. So x bar, let x bar be the sample mean corresponding to the given sample size. So there's 3 different ones in 10. And all you're supposed to do for 10 is use A, B, and C, these facts right here, to talk about the 3 different sample distributions, because you have 3 different sample sizes. Hold on, I'm flipping back in my book. It was 4, 16, and 100. So A just says flat out the sample is going to be normal because x was normal. So it doesn't matter what the sample size is. You have A, so you should write that down for 10. It tells you what the mean is going to be. And again, the sample size doesn't matter. It tells you what the mean of the sample distribution is going to be. It's the same as what the mean was for x. And then it tells you the standard deviation of the samples and how those will vary. And here's the formula for those. And so that is going to change for each of the n. So for 10, you need to note that all 3 of them are going to have these 2 characteristics from A and B. That's what they're going to have in common. And then C, they're going to have different standard deviations, and list the 3 different standard deviations. So use this formula to figure out what the standard deviation would be for those 3 different sample sizes. For 12, we have x is normal, gives us the mean and standard deviation. And we're trying to find the probability of that x will be less than 120 with this information, greater than 80, so a less than or equal to, a greater than, and then in between 2 numbers. So 3 different types of problems. But all of them can be done using Excel. And Excel has a great formula where I have different numbers here just to mix it up so I'm not directly answering the question for you. I said the mean's 100, the standard deviation's 5. If that's true for a normal distribution, so the average x comes out to 100, what's the probability that a given random x will be less than 105? You can use the formula normal distribution, because x is a normal distribution, and it tells you the parameters here. The first one is, what is the x we're checking? So we're checking 105 here. What's the chances we're less than 105? What's our mean? I said 100. Standard deviation is 5. And then we want cumulative to be true, because that's what we're asking. What's the chances x is anything less than 105? So that's what true gives you. It gives you everything accumulating all the way down from 105 all the way down. So the chances that a random x would be less than 105 with this information is 84%. So the way you do a greater than, you have to subtract the answer from 1. So I would have, again, 105, 100, 5, true. But just like that first one I did, that's the chances of x being less than 105. So if there's about an 84% chance of being less than 105, that means the rest of the time you have to be bigger than 105. So subtract that from 1 and you get 0.15866. So these 2 numbers add up to 100% because you're either less than 105 or you're greater. So for any greater than, you're just going to do 1 minus your answer, because just using normal distribution, gives you the probability of being less than. So you have to do 1 minus the answer to do a greater than. And then if you're doing in between, use normal distribution for both of them. So 100 and then 100 again. The mean that was 5, true. And then for 110, norm.dist 110 means 100, 5, true. So the probability of being less than 110 is this. The probability of being less than 100 is that. You want to subtract the bigger one from the smaller one. F2 minus E2. So the probability of being in between those two is 0.47725. Let me illustrate that with a graphic. So Excel said that the probability of being less than 100 was 50%. So that's just the green area, less than 100 on down. And then the probability of being less than 110 would be everything colored in. So from 110 all the way down. And it said that was 0.97725. Well, if you just want the probability in between this, we would just be looking at the blue then. So if we're just looking at the blue, it's like getting rid of the green. It's like subtracting the 0.50 from that. And if you take that and subtract the 0.50, that's what we got here. We subtracted the 0.50 and got 0.47725 as the probability of being in between 100 and 110.